Okay, so we're going to follow on with second part of these component um, vector problems. The last one, part one of component forces, we discussed the I, J, and K and how they come about, and I did a brief example. The next one is trying to figure out the uh, direction of these forces, and I'm going to lay this out first from a three-dimensional standpoint. So with that, let's get a ruler out here, and we will try to lay out something that will make some sense to everyone. Black, please. So if I got this and this, we should recognize this as X, Y from the way the math world draws these and gives you some perspective of why we choose what we do. And if I draw this through here, then I'll have Z out here. Okay, and this helps us lay out our vectors and start thinking three-dimensionally. Now, in the classroom, usually what I wind up doing is getting a meter stick out, putting it in the corner of the room, and helping everybody identify the three angles that would go on if I took it out from 45 degrees up and out of the corner and off from both the XY wall and the YZ wall. But here when we sketch them out, it's a little bit more complicated and not as easy to see. So I want to make some planes with this so you can start seeing some things. And then from that we can have some perspective of what we're going to do. So first thing I'm going to do is this. We're going to draw this and this. And this is going to be in the X, Y plane. And I want you to recognize, oh yeah, we should put the origin down here too, that this plane has a shape. It's in the positive X, positive Y, and it's at Z equal to 0. Okay, or basically on plane with the origin. Okay, so some value of X, some value of Y, and literally it can be written as it's positive, positive, and I could be a negative Z where I go back in that direction, but basically that's the plane I'm looking at. Okay, so I don't want to get you confused with that yet. I just want you to start used to seeing these things. So I'm going to do this through here to give you some examples. All right, and in the beauty of having color available to us, we're going to do this one to this one. Okay, and this will be the in the blue. Let's do this. In the blue, this will be the YZ plane. Okay, and it'll have X is equal to 0 with some positive Y and a positive Z value. Okay, now there could also be a negative out there if you want to go that way. Just keep that in mind. I'm only drawing on the front quadrants of this shape. All right, and the last one will be this one. Okay, and this will be the XZ plane. And that'll have a positive X, Y is equal to 0, and Z, and a positive Z. All right, and by what I mean positive, you're going to get a value out there someplace in that plane. Okay, and it should look like all this. And that'll be the planes we're playing with, okay? It can get really complicated and really messy, and I don't want to make it too messy, but if you're having some confusion with this, just draw the two planes that you're operating in. Most of statics will work out so it's in the XY plane or the XZ plane. It's when this gets complicated and we do things like flagpoles and we got tension cables coming off the top of the flagpole, it will have three different planes. And we're going to do an example like that, so a little later on here. Don't panic. Okay, we can get rid of the ruler for a bit. All right, now part of this was to figure out where are the directions coming from. Okay, so let's do a few simple things here, and it's kind of a review of the other day, but I want to make sure we get some facts and figures down here. So if we look at this, I guess I want a black pencil. F of x is equal to the force cosine theta x, and F of y will be equal to the force cosine theta y, and F of z will be equal to F cosine theta z. Okay, so the thetas are our angles, and I guess it's time to put another grid or coordinate system on the chart. Let's do that. 90 degrees, please. There, and we're going to come out at a 45, and they're always drawn at a 45 to each other. So basically all planes come out at 90 degrees. Okay, but I'm going to put a vector in here, and this is going to drive some people absolutely nuts. So don't panic with this, but just try to follow along. So I'm going to do this, and right now you have no idea if that's in the some labels on this. That's X, Y, and Z. And I always personally try to draw the axis labels in the positive portion of the plane. All right. Now, where is this going to be, and how is this going to get to where it's going here? All right. So if I do this, let's start with sigma y. So if I go this way, that'll be, tell you what, I'm going to change that pen thickness. That becomes sigma y. Okay, but then I have a sigma x from the x-axis here. That's sigma x. And then, of course, I can have one from sigma z. Okay, so if I'm playing this out, where this plane's actually working is I'm in the backhand portion of xz and up in the xy plane. All right, so I'm back over in here someplace. So if I was to, I'm trying to think, always trying to find a better way to draw this for people, but I am back in here and I'm moving up. Okay, so that would come back over into this plane and move up in the y. Okay, and so let's call that one y prime. And so it's moving up and out, up to the right and back out of our point of view. Okay, just to put it in somewhat perspective there, so where you are. All right, so if we write this, we're going to take this information we've got up here plus the stuff I introduced you to in the last chapter or last video, and we're going to write F with the vector symbol is equal to f of x I plus f of y j plus f of z in a lowercase k. Okay? And those are the important things. Remember, these guys are the unit vectors. Okay? So it's probably worth a note there. I, j, and k are unit vectors. Okay? And that'll help you with that. Now, we know already from this up here that f of x is equal to f cosine theta x and f of y is equal to f cosine theta y and all that so across there. We can now make some substitutions into this equation to help us start figuring out what we're doing. So f cosine theta x, and we still have the unit vector out here, f cosine theta y in the j plus f cosine theta z in the k. All right, and that helps us write everything about this vector of f. Oh, and I should have labeled that up here. That's our f vector. Okay, so it's that we're trying to find. Okay, and we're going to give some angles, and we're going to give some things related to that. Okay, now I've got a few rules that I wish I had got credit with inventing, but I didn't. But these are the rules we need to play with. Okay, so let's get some rules to the organization of this. Okay, so the angle of vector f is measured Okay, so we're going to measure this, and I think there's a time right now to throw this in there, and then we're going to give you some more rules with this. So let's take this for a minute and just play this out. So there's x, there's y. I put a vector here. Okay, it's this angle here, theta, that we're measuring. It's always going to come from the x all the way over. Okay, but it could be, let's do a different one. It could be a vector here. Okay, and it's going to come from there. Okay, so that'd be theta 2. That one will be theta 1. Okay, and F2, be nice to print. There we go. So you can see where those are coming from. And we're always measuring from the positive. So it's always from the x over. So if we went clockwise, or counterclockwise, I mean, we'd be going in a positive direction around from x equal to 0 all the way around to give us those vectors, or those angles to that vector. Okay. All right, now let's have some more of these rules. And don't need you popping up there. If theta x is greater than 90 degrees, all right, what's going on here? Hold on, I'm going to pause for a minute. Something just went screwy with my surface. Don't go away. Okay, we're back. Somehow a blank just showed up down there where the keyboard was supposed to be. All right, so if theta x is greater than 90, and is on the same side and the same side of the XYZ plane as the positive axis. I guess I should put the word thought in there. As the positive x-axis, okay, such that the theta x will be cosine theta x and fx will be positive. Okay, I'm sorry, I said theta x is greater than. It's actually theta x is less than 90 degrees and is on the same side as the xyz plane as the positive x-axis, such that f of x and cosine x will be positive. So basically, remember, I'm looking at z out here. So if it's on the right hand side of this out here, this way, anywhere in there, that'll be positive. Okay. If x of x, or theta x of x, if theta of x is greater than 90 degrees, okay, okay. So if theta x is greater than the 90 degrees, this indicates the vector f is on the opposite side of the yz plane. So that'd be my f2 vector up here that I got in red, such that f of x and cosine of x will then be negative. Okay, so you can put a negative sign in front of that. And it goes back to, if you can think about this, it goes back to the positive in the first quadrant, the negative positive in the second quadrant, the negative in the third quadrant, the positive negative in the fourth quadrant when you're on the XY plane and doing all the math that went with that. Okay. The other thing this does for us, and it'll keep statics a little simpler for you, is that we're always looking for the angle from the zero axis, or in the positive x-axis in this particular case, all the way over. So we could have an angle of 45 degrees, or we could have an angle in the second quadrant that's 135 degrees. So there's none of this guessing as to which angle I'm playing with. And That'll make your life a little less confusing and hopefully a lot more helpful. Okay, so there's that. I think I'll pause this here and I'll come back with part 3 and we'll do an example so you can see how this works.